Okay, so this is a simple Tripoli project, electrical and electronics engineering project integrated with machine learning, and I have used here k-means as a machine learning algorithm. So in this video, first I will tell you that what is k-means, the basic of k-means, the theory of k-means, and then I will share you that what I have done here. Okay, and I will also tell you that how many projects are in this video. So first let's work with k-means. So basically, what is k-means? So let me give you one example. Let's say at the x-axis and at the y-axis, first let's say you have some students, let's say S1, S2, S3, and you want to take the CGPA and IQ data of the students. So for the first student, CGPA is let's say 3.5, IQ is let's say 120. For student 2, CGPA is 4, IQ is let's say 160. For student 3, let's say CGPA is 3.8, IQ is let's say 150. And again, by going similarly, let's say you have 50 students or 100 students, whatever you have, let's say CGPA 3.6 and IQ is let's say 130. And now if you want to plot this thing here for all the students, at the x-axis you will have IQ, and at the x-axis you will have CGPA, and you can see that this data looks like this. Some students stays here, some students stay here, and some students will stay here. So there are three kinds of students here. So these will be called cluster 0, these will be called cluster 1. That means in cluster 1s the students are similar, their IQ and CGPA has similarity, and similarly these are similar students, their CGPA and IQ both are high, their IQ is low but CGPA is medium, their IQ is high but CGPA is low. So these are some similar students or category 0, these are category 1 or cluster 1, and these are category 2 or cluster 2. That means what this k-means actually doing, this k-means actually find the similar students and then classify the students according to the cluster. So that means this is actually the k-means. So k-means will assign these students into specific cluster. Let's say if you run this algorithm, you can see the student 1 is at the cluster 0, student 2 is at the cluster 1, student 3 is again at the cluster 0, let's say student 50 is again in cluster 0. So this algorithm looks like this. So similarly, but now the question is how many clusters are here. We can see that there are 3 clusters, right? But we are humans, but we have to write a code, but this code is not human, so it cannot see. It should have some algorithm to find the cluster number. Let's say I found that here the cluster number is 2, but how this Python code will understand what is the number of cluster. So now our task is what is the number of cluster, what is the number of cluster. So now how to find this thing. So if we want to find this thing, we have to find WCSS for each n cluster. So now what is this thing WCSS? Let me tell you that. So if I go to ChatGPT, you can see that WCSS is called the within cluster sum of squares, and the formula looks like this. So what this thing actually, let's see. So basically, let's say you have some data. Sorry, let's say you have some data looks like this. Okay, so let's say you have some data looks like this, and you don't know what is the number of cluster. Let's say you have assumed that number of cluster is, let's say, 2. That means you will assume that these are cluster 0 and these are, let's say, cluster 1. So now what you will do, or let me assume that there are number of okay, let me do another thing. Let me add another cluster also. Let me assume here 5 cluster. Okay, now you assume that here your cluster number is 4. These are the actual data, and whatever the actual data is, let's say you assume that number of cluster is 4. So you assume that these are cluster 0, these are cluster 1, these are cluster 2, and you choose that these 2 are cluster 3. That means there are 4 cluster. So what you will do, that you will find the centroid or the center position and find the difference between all the points of this cluster. I mean, all the points mean, let's say, d1 square, d2 square, d3 square, dn square. I mean all the differences of the cluster 0. And similarly you have to find the centroid of cluster 1 and find the difference square. Find the difference square of all the points. So let's say those are, let's say d prime 1 square, d2 prime square, d3 prime square, and this will go on. And similarly you have to find the centroid and the distance square between the points and the centroid, and you have to sum all those numbers. Let's say d prime 1 square, d prime 2 square, and so on. And similarly you have to find the last cluster's centroid, and you have to find the distance square between the points, and then you have to find the differences. And then what you will do, you will sum all the things, and this will give you WCSS. Okay, so what I will do now, so first I will, let's say this is WCSS, and I will first assume that number of cluster is 1, and then I will find the WCSS. Then I will assume that number of cluster is 2, and I will find the WCSS of the data. Again I will do it for 3, I will do it for 4, 5 and 6, and I will see that the data looks like this. That means you see here is a breakpoint, and after this breakpoint the line is flat. So this break happens in n is equal to 3, so the number of cluster is equal to 3. But if you see that the graph looks like this, that means the graph is almost flat after 2, so we will say that the number of cluster is 2. So this, by this thing you can find the CSS, I mean you can find the number of cluster. So now let's go to our code. So let's see what this code is doing. So we have to import this thing, basically this thing, sklearn.cluster module. We have to import this k-means. Now you can see that I have some data here. And I have data from day 1, day 2 up to day 7. So I have 7 days data. And what this data is telling me about, this is the 24 hours power uses, and these powers are in kilowatt. You can see that what is x dot shape. So there are actually 7 rows for 7 days and 24 hours power uses. So you can see this here. So now what our task is here, our task is, it's normal that if it is Sunday, your power uses will be one kind. If it is Monday, your power uses will be another kind. And if it is Friday, your power uses will be some another kind. So you have to find the cluster. That means, let's say D1 and D6 are similar. Similarly, the power uses of D7 and D2, let's say D3, let's say similar. So you have to find the similar and divide them into cluster. But first you need to understand what is the number of cluster. So again, you have to find this kind of curve. Okay, basically this curve is called the elbow curve. Okay, we have a name here. This curve actually called the elbow curve, where y-axis has WCSS and here you have n cluster. So let's find the elbow curve. Okay, so here I have just normalized the value. Normalize the value means I have just divide them with the maximums. I mean, let's say that this is the x means this data actually, and I have find the normalized input by doing this. Let's say x is 0.3, 0.4 for day 1. Let's say for day 1 the power is 0.3, 0.4, 1.5. so this is 1.5 is the maximum. So I divide all the kilowatt power in specific hours by the maximum numbers, and for day 2 the maximum is 2, and again I have divided by 2 all the numbers. So thus I will get xn. So you can see I have divide x by the x max. Okay, so if I do this thing, I will get xn, and you can see if I write here xn, so this is actually xn, and all the numbers are less than 1 because I have divided them with the maximum numbers. And now for this part of the code, I have to find the WCSS. So what I will do, I will run a loop where I will be from 1 to 6, and by using the k-means, this k-means is this k-means, which is from the sklearn.cluster. So I will use this k-means, and I will first assume that I is equal to 1, then I will assume that cluster number is 2, cluster number is 3, and similarly cluster number is 6, and then I will fit predict. That means I will change this input data, and then I will find the WCSS. This km.inertia actually gives you the WCSS value, and then I will plot this thing, and let's see what is this. So this is the WCSS graph. So at the y-axis you have WCSS, and at the x-axis you have you have number of clusters, and you can see that after 3 here is a break, and after 3 the graph looks like flat, not totally flat but approximately flat. So I can assume that number of cluster is 3. So that's why I at the next part I have assumed that number of cluster is 3, and then again I have predict this, I have feed this value, I have trained this input value, and this y predict, that I should write here that cluster group. Okay, now if I run this thing, and if I try to find what is cluster group actually, so this is actually the cluster group. And let's talk about this output. Let me copy this thing and paste here. Okay, so what this actually means, so basically this is day 1 and this is day 2 and this is day 7. This day 1, day 2 and day 7 are called cluster 2. Then this is day 3, day 4, day 5, day 6. You can see that day 3 and day 6 are included into cluster 0. That means the power uses of these 2 days are similar, and similarly day 4 and day 5 are in cluster 1. That means these days have some similar power uses. So thus you can find the similar days like this, or the similar power uses of the days. But to be honest, if you look here, I will run this, and you can see that for different times you have some different values. You see that these twos are similar, and if I run this again you can see this these twos are similar again. Yeah, these two are similar, but yeah, now you can see that first 3 are similar. That means you can see these two are similar, these two are similar. That means these two has some strong similarity, and that's not the problem that this is 2 2 and this is 0 0. That's not the problem. It can be happen that you call sometimes that is cluster 0, or if you call sometimes that is cluster 2. That is not the problem. The fact is, you can see that these two are similar, these two are similar, and again these two are similar. That means these two has some strong similarity. Again you can see these two are similar, these two are similar, these two are similar, these two are similar. So we can say that these two has a strong similarity. But you see this 0, this is 2, and this is 1. So we can say that this day, the day 3 is sometimes attached with them, and sometimes it attached with it. So it depends actually. So basically you can say that the power is like intermediate to another 2 groups actually, and that's why this is happening. So you have to run this code again and again, and you have to understand the similarity actually by yourself. So that is the task. Okay, so now you can see that 2 2, I mean this and this has, I mean these 2 days have some similarity. So what I have done, that I have find the power versus hour graph. So I will now try to find the hour, which will be in the x-axis. You can see from 0 to 24 hour, and then I will find the first day's value. I should use normalized value, and now let's see. So you can see that these 2 graphs look similar. You can see that these 2 graphs look similar. That means yeah, these 2 days has some similarity, and similarly you can see that these 2 days have also similarity. Let's see, 0 1 2 3 and 4. So let's see, let's write here 3 and let's write here 4. Yeah, you can see that these two days power has some similarity. Power versus hour graph has some similarity. Red is for day, uh, day blue is for this, and red is for this, and we can see that these have some similarities, and that's why here you have 0 0. But let's see, is there any similarities between this day and this day? Let's see. So this is x0 and this is x3. Let's see what happens. Oh, you see that these two graphs are not looks like similar. Similarly, let's see with this and this. Let's say this is 6. Not too much similar. You have here, you have some curves here, this non-similarity, but looks pretty same. And let's see 5. Oh, this is also not looks similar. Okay, so by taking these graphs, you can find the similarity or dissimilarity between the days.